have this example for the function f whose graph is given, determine the following limits. So we have graph of a function, and we need to determine the following limits. So the limit of the function when x approaches 2, Okay, let's grab this vertical line, passes through x equals 2 in here, and track the value of the function to the left and to the right, or the limits from left side and from right side. You see that both will come closer to, let's have highlights here, or creative stuff. Yeah, let's do that here. Funny stuff. Okay. So if we track the value of the function from left side when x equals 2, or say approaches 2 from left side, the value of the function is 0. And from right side, when x approaches 2 from right side, the value is 0. So the value of the limit of the function equals 0. Okay, equals 0. Now, the limit of the function when x approaches -3 from right side. This positive means right side. Okay. From right side, and this is -3. Yep, -3. So this is -3 over here. And this line, the vertical line, pass through x equals -3. So let's look at right side limits. So from right side, you see this is our curve. When x approaches -3 from right side, you see that the function, the limit of the function will be about -2. From right side will be -2. Okay. And from left side, it will be 2. Two different values. From right side here, right side, it will be 2. And from left side, it will be, from right side, it will be -2. And from left side is 2. Yeah. So the limit of the function when x approaches -3 from right side, and the limit of the function when x approaches -3 from left side. Let's do that here. Okay. So from right side, it will be -2. From left side, it will be 2, as you see, 2. So from right side is -2, from left side is 2. Now they tell us the limit of the function when x approaches -3. They didn't tell us from right or from left. Did that mean we have to compare right and left? If they are the same, then it's the same limits. But if they are different, we'll say does not exist. Does not exist. The function doesn't exist. Here. Prefer to say GE, doesn't exist. Okay. Limit of the function when x approaches 0 from right side. From right side. I see that you answered already the question. I could hear you. This is 0 here. The function goes through 0. And it has different sections. And this is our line, the dotted line here, imaginary line. It doesn't include in our graph, but we imagine that we have line pass through the given points here 0 and we track the limits from right side. It will be, I hear you, it's -2. And from left side, where it goes left side, where it goes the function, to positive infinity, to the heaven, to the sky, this blue line. Okay, so again, let's write our information here. Okay, so the function, the limit of the function when x approaches 0 from right side is -1, and from left side it's infinity, goes to infinity. So since we have two different limits, we'll say the function doesn't exist. dn or da doesn't exist. Again, we still have like a couple questions. The limit of the function when x approaches infinity, it goes to infinity. Imaginary. It goes to where? And to negative infinity, it goes to where? Okay. Right. Again, the limit of the function when x approaches infinity. So this is our line. The function goes crazy, jump, go up to the heaven, jump back here and continue, go on forever. But actually, it almost touch this line, x equals 1. Let's rotate it. The function almost touch x equals 1. That's the kind of horizontal asymptote. X equals 1. So it will be equals 1. Now negative. Now we have negative. The function, as you see, it goes to infinity, but almost will touch x y equals 0. Almost touch y equals 0, x-axis here, this one. So the function goes to infinity, but it will touch, almost touch x-axis, which is y equals 0. So it will be 0. This is today's question.